it's Princess Parame here with some exciting examples on stoichiometry. But before we begin, we should know first that there are three types of conversion factors in stoichiometry. First is the molar mass. We use molar mass whenever we are converting grams to moles or moles to grams. The second one is the mole to mole ratio, and it is found in our balance equation. And the last one, the third one, is the Avogadro's number, in which we use the Avogadro's number whenever we see the keywords, particles, atoms, molecules, and formula units. So guys, we have now our unbalanced equation, a hydrogen reacting to a nitrogen to produce ammonia. So guys, we should always remember that in every stoichiometric calculations, balancing the equation is the very first thing to do, because we cannot proceed in any stoichiometric calculations without a balanced equation. So to balance this equation, we should add coefficients in every compounds. For hydrogen, we should add 3. For nitrogen, we should add 1. And for ammonia, we should add 2. So our balanced equation now is 2H2 plus 1N2 to produce 2 ammonia or 2NH3. Now that we are done in balancing with our equation, which is our final balance equation is 3H2 plus 1N2 is equals to 2NH3, we can now jump into solving problems. So number one problem is how many moles of nitrogen are needed to react with 7.5 moles of hydrogen. So we have here our given 7.5 moles of hydrogen, and what we need to find is the moles of nitrogen to react with the 7.5 moles of hydrogen. So here it is, our answer. Our given 7.5 moles of hydrogen times what we are finding, nitrogen, divided by 3H2, which can be found in our balanced equation. Cancel the H2 and then do the math. Now our final answer is 2.5 moles. So we have now our second problem. Our second problem deals with how many grams of NH3 is produced if you react 42 grams of nitrogen. Our given 42 grams of nitrogen, and what we need to find is the grams of ammonia to produce or react to 42 grams of nitrogen. So first, we have here our mass for nitrogen times 1 mole of nitrogen divided by the molar mass of nitrogen in grams. And the answer will be the moles in nitrogen times coefficient in H3 divided by the coefficient of N2, which is found in our balance equation. And the answer will be the moles of NH3 times molar mass of NH3 in grams and 1 mole of NH3. And the final answer will be the mass of NH3. Is our vivid solution for the problem. So 42 grams of nitrogen given times 1 mole of nitrogen divided by 28 grams of nitrogen. And then cancel out. Do the math. And now we get 1.5 moles of nitrogen. So we use the 1.5 mole of nitrogen to multiply to 2NH3 divided by 1N2. Cancel out N2. And now we have derived to 3 mole of ammonia or 3 mole of NH3. 3 mole of NH3 multiplied to 17 grams of NH3, the molar mass which can be found in our periodic table, divided by 1 mole of NH3. And now we have the final answer, 51 grams of NH3. So for the third problem, I will be introducing to you Avogadro's number. At the same time, I have used a different balance equation. So here it is, our new balance equation. So let us now jump into solving the problem. So the problem is, how many molecules of carbon dioxide are required to react with 174 grams of carbon monoxide? So our given 174 grams of carbon monoxide, and what we need to find is the molecules for carbon dioxide. So this time I will show you the answer. We have here our given 174 grams of carbon monoxide multiplied to 1 mole of carbon monoxide divided by molar mass of carbon monoxide, which is 28.01 grams, and then cancel out grams for carbon monoxide times 2 mole of carbon dioxide divided by 2 mole of carbon monoxide, cancel out mole carbon monoxide, and then multiply to Avogadro's number, which is equivalent to 6.022 times 10 to the power of 23 molecules divided by 1 mole of carbon dioxide, and then cancel out mole for carbon dioxide. And now we have our final answer of 3.74 times 10 to the power of 24 molecules. Thank you for watching my tutorial and keep learning.